Yes, students, let's start class today. An extra class on the topic expansion. Okay, thermal expansion. That's where we stopped yesterday. So we are starting from here, and what we saw from thermal expansion, we saw that there are three types of thermal expansion that we study. One is linear expansion, one is areal expansion, and third one is volumetric expansion. Okay, and change in length because of the change in temperature, we said that is equal to L alpha delta T, where alpha is coefficient of linear expansion. Same way, change in area, we said that A beta delta T, and change in volume, said V gamma delta T. Alpha is coefficient of linear expansion, beta is coefficient of areal expansion, gamma is coefficient of volumetric expansion. So delta L by L, okay, is equal to alpha delta T. But in this one, sometimes they ask you final length. Final length is what? Now delta L basically is what? LF minus Li. LF minus Li equal to Li alpha delta T. So L final is actually L initial into 1 plus alpha delta T. Exactly same way, area final equal to area initial into 1 plus beta delta T. Delta V final equal to V initial into 1 plus gamma delta T. Okay, that's how we used to find the final length, final area or final volume. And in the previous class we already have seen alpha is to beta is to gamma is 1 is to 2 is to 3. Okay, right. So let's see certain questions on this one. See, very simple question here. It says that length at 20 degrees centigrade is given to you as 8 meter, and the same rod or same wire, its length at 80 degrees centigrade becomes 40 meter. So what is its length at 50 degrees centigrade? Okay. So one way is there that we can use our formula that we have saw, what we have seen right now, LF equal to Li into 1 plus alpha delta T. But first I would like to tell you it in a different way. Okay. What different way? We are going to do it with the scale that we use in thermometry. The same scale we are going to solve it. Okay. One formula I told you. That formula I am going to use. What is that? Let's see. I told you that T minus lower temperature by higher temperature minus temperature or rather lower temperature equal to value of property there. Okay. So value of property at corresponding to temperature T minus at higher temperature by property value at higher temperature minus property value at lower temperature. This I am going to use and directly you will get the answer. So what he wants? He wants at 50 degrees centigrade what is the length, right? So this is 50 minus temperature lower is what? 20. Higher temperature is what? 80. Okay. And this is 20. Now length at that temperature 50 we have to find. So let it be L minus length at 20 is 8. Length at 80 is 40 minus 8. That's all. Okay. So this is 30 here and this is 60 equal to L minus 8 by 32. This is 2. This is 16. The 16 equal to L minus 8. That is L equal to 24. That's all over. Finished. Now in this one I did not use alpha or anything. Not required. Okay. We solved it with this itself. And my suggestion to you is solve it like this one. Okay. But if suppose you wanted to go with alpha, the question asks you alpha also. If, then what you will do? First we are going to, in this one, first we will use these two to find alpha. Okay. So what formula you will use? L80 equal to L40, no, L20, sorry. L20 into 1 plus alpha into delta T. How much is delta T? 60. Okay. L80 is what? 40. And L20 is 8 into 1 plus 60 alpha. So this is 5. 5 minus 1, that is 4. 4 equal to 60 alpha. So, alpha equal to 1 by 15 per degree centigrade. Okay. Now, we are going to use it into 50. So, what you will write formula? L50 equal to L20 into 1 plus alpha 50 minus 20. Okay. L50 we are calculating. So, L50 as it is, L20 is 8 into 1 plus alpha value, that is 1 by 15. And what is delta T here? 30. So, here is 30. Okay. So, 15 to 30, 2 plus 1, 3, answer is 24. Okay. This answer we got in 3 steps. Here also 3 it looks like, but here first we found alpha, then we are using this to calculate, put alpha and then find it. Okay. So, my suggestion is if directly length they are asking, we can use this one and get the answer directly. Okay. Alright. Let's move ahead. So, thermal expansion when we are doing, in pendulum also they ask us that if the temperature is changed, then time period of pendulum also changes. Okay, the reason is because wire is there which is through which the bob is suspended, and once you are increasing the temperature, length of the bob is changing, and because of which time period also changing. So, what is time period formula actually? We all know T is equal to 2 pi root over L by G. Okay, so time period is changing because of which property that is changing? The time period is changing because length is changing. Okay, so length is changing because of change in temperature. Okay, the remaining things are all constant. 2 pi constant, G constant, everything is constant. So what I am going to do is, we have learned in through error. If I am going to find, suppose I ask you that what is the possible change or what is the possible error in this time period. So we would have written something like this: delta T by T is equal to half delta L by L. Okay, delta T by T equal to half because its power is half, L to the power half. So half delta L by L. Correct. Now, because of change in temperature, now remember that this is okay. Shall I do it in small t? Okay, that will be better. Otherwise, in temperature and time, you would be confused. So this is T. Okay, and delta T by T. Okay. So this change in length is happening because of change in temperature. So delta L formula is what? Delta L is what? L alpha delta T. Okay, so put L alpha delta T here. This is half L alpha delta T by L is cancelled. So delta T by T is equal to 1 by 2 alpha delta T. So if they want that how much change in time period has happened, that is half alpha T delta T. That's all. That's all. So if we know the value, okay, change in temperature, alpha and original time, we can easily find how much change in time period is coming. That's it. No need of derivation of as such, how much the changes are coming, directly we can do with the help of error. Okay, this we use what? Error. So this is your shortcut. Okay. If you have to frame, you can frame it also. If suppose I frame a question over here. Okay. So if you are framing question, alpha value, let's say it is 2 into 10 to the power minus 5 per degree centigrade. Okay. Then the time period, original time period is 1 second. And delta T that you have is, let's say, increase in temperature is 40 degrees centigrade. Okay. So how much is increase in the time period? Okay. Delta T. Put it 1 by 2 alpha into T into delta T. That's it. So 1 by 2 into 2 into 10 to the power minus 5 into T value is 1 second and delta T is 40 degrees centigrade, that is 40. This is cancelled. So we have 4 into 10 to the power minus 4 seconds. This will be the change in time. Okay, this way we can find it very easily. This is for a pendulum, or for any other thing also. If you know the formula, directly use the error formula, get this kind of a relation and solve it. Okay. Okay. So now let's see thermal strain. What is thermal strain? Now suppose that this is rod of certain length which is fixed between two walls. These are walls. Okay, and we are increasing its temperature. So temperature normally if it is increased, we know that this wire's length will increase. But in this one, we are not allowing it because here is also wall, here is also wall. We are not allowing. So if we are not allowing, will thermal strain will be developed? Answer is yes. Yes, that is only thermal strain. When actually thermal stress and thermal strains concepts are what? Thermal stress, or rather stress in general concept, is the force which is acting in opposite direction, which is opposing the increase in length. That is only what that was creating the stress. The force which was opposing the change in length. That's how we were coming back. Then we studied in elasticity, the property due to which it will come back to its original shape and size. So who was bringing it? This opposition force only. So opposition force creates the stress. So here who is the opposition force? This opposition force is basically created by this wall, normal force of that. Because due to change in temperature, due to increase in temperature, length should increase. Who's opposing? Wall only. Okay, so there is opposition force. So that's why stress will be there. If suppose that wall is not there and you are increasing its temperature, then there is no stress. Okay, no stress then. Right? So no stress, so no strain, nothing. This entire thing will come only when you are opposing its change in length. Then only this concept will come. So remember. Okay, so thermal stress, thermal strain first. So thermal strain is what? Delta L by L. How much change would have happened, that we are writing. Okay, so delta L by L. What will come? Alpha delta T. So alpha is also given, delta T is also given. Directly we can write. That is thermal strain. Okay. Then thermal stress is what? And in this one, Young's modulus is also given. So Young's modulus is what? We know that stress by strain. Now here it is thermal stress by thermal strain. So strain you already got. So stress will be what? Stress is equal to Y alpha delta T. So just Y we have to multiply. Delta L by L you have calculated already. Multiplied with Y, you got stress. Then force. Okay. Now stress is what? Force exerted by wall by area equal to Y alpha delta T. So force exerted will be what? Y A alpha delta T. That's all. Everything is given except area. Area I have not given in this question, right? So area also you take, say 2 centimeters square. Okay, so Y is given, area is given, length is given, whatever here, length in fact is not required. Nowhere it is required. This is alpha delta T only, this is Y alpha delta T, and this is Y A alpha delta T. Okay, so this is the concept related to thermal stress, thermal strain, and restoration force. Okay, that is actually the force exerted by wall on the rod. Okay, or rod on the wall or wall on the rod, both are same. Okay, all right. What this is now? Okay. So gamma for glycerin is given 5 into 10 to the power minus 4 per Kelvin. This is gamma. Okay, gamma for glycerin. Fractional change in density of glycerin for a rise of 40 degrees centigrade in its temperature. Fractional change in density. That means he is asking d rho by rho or delta rho by rho. Okay. Now what we know about density? Density we know is mass by volume, or density is proportional to V to the power minus 1. Mass is constant anyhow, right? So again, if I am going to use that error concept, then I know d rho by rho I'll write as minus dV by V, because density is inversely proportional to volume. When volume increases, density decreases, and volume decreases, density increases. So same thing over here, d rho by rho equal to minus dV by V. That means if I have to find frictional change in density, then frictional change in volume also will do for me. Only thing is to be negative. Okay, fine. So volume change means what? dV means what? dV means V gamma delta T minus V gamma delta T by V. That's it. This is cancelled. Okay. So if gamma is given to me and delta T is there, that means I have d rho by rho. So gamma is there, delta T is also there. So put it minus 5 into 10 to the power minus 4 into 40. That's all. That will be minus 200 into 10 to the power minus 4. That is 2 into 10 to the power minus 2. Minus means minus represents what? It is decreasing, nothing else. So fractional change is 2 into 10 to the power minus 2. That's it. Do you see that how we are using this error? Okay. Move ahead. These are all P by Qs, okay. This is P by Q actually. Next. Okay, two rods are there. You can see that this is the rod, its length is L1, its coefficient of linear expansion alpha 1. The other one, its length is L2 and coefficient of linear expansion alpha 2. Okay, what it's asking? What should the condition be? What should the condition be so that difference in length of two rods remain constant with change in temperature? Okay, so it means is whatever is the difference in length, it should be constant, irrespective of what temperature you are making. If presently suppose temperature is 15 degrees centigrade, you are going to make it 20, 25, 30, 35. This difference in length will be constant. That's not going to change. So what is the difference in length here? You can see that is L2 minus L1. This will be constant. This should not change. Okay. Fine. He's saying find the condition. So let's see what condition we can write. So at the moment we know that L2 minus L1 is constant. Okay. So will this be constant after temperature T also? After increase in temperature T also? It should be, because the question is saying. Let's see. So L2 minus L1 initially should be equal to L2 minus L1 at some temperature T also. Right. So let's see. L2 minus L1 equal to. Now I am taking it to temperature T. So what I'll write? L2 into 1 plus alpha 2 into T. Okay. Minus L1 into 1 plus alpha 1 into T. This will be the final, initial length are L1 and L2. I increase the temperature by T. So then length become this and this become this. What you can do? Then L2 minus L1, this is L2 plus L2 alpha 2 T minus L1 minus L1 alpha 1 T. So this L2 and this L2 here is cancelled. Okay. So here this and this is cancelled. L1 also minus L1 and minus L1. Now what we can do? This L1 alpha 1 T we can bring this side. So bring it. Okay. So L1 alpha 1 T, L1 alpha 1 T equal to L2 alpha 2 T. T is also cancelled. So condition is L1 alpha 1 equal to L2 alpha 2 or L1 by L2 is equal to alpha 2 by alpha 1. Anything. This is the condition which says that no matter what the temperature you are increasing, this L2 minus L1 will remain constant. Okay. Alright. Now, the density of water at 20 degrees centigrade is 998 kg per meter cube and at 40 degrees centigrade it is 992. the coefficient of volumetric expansion of water. Okay, so the question gives you information about density and he is asking you what is the coefficient of volumetric expansion. What is coefficient of volumetric expansion? Gamma. Okay, what we know that delta V equal to V into gamma into delta T. Okay, this is it. So what is gamma actually? Delta V by V delta T. Okay, now this delta V by V I can also write as dV by V. Okay, and this dV by V in the previous question, one of the question we wrote as d rho by rho. Okay, minus d rho by rho though. So we can write that also. Minus d rho by rho into delta T. What question is asking? Coefficient of volumetric expansion of water. Said okay, volumetric expansion of water is this. And what is given? Density of water at 20 degrees centigrade is 998 and at 40 degrees centigrade is 992. That means d rho. Delta rho is given rather. If we want this to write as minus delta rho by rho into delta T. Let's put the value. What is delta rho? Delta rho is 998 minus 992. Okay, actually final minus initial. So 992 minus 998 by initial value 998 into change in temperature. What is that? 40 degrees centigrade. No, 40. 20 to 40. Okay, 20 degrees centigrade. So delta T is 20. So 992 minus 998, that is 6. 6 by 998 into 20. That's all. That's gamma. As simple as that. Okay, so this way we can find out that what is the gamma value from the given question. Alright. Okay, then now we'll start calorimetry. Okay, so I'll take 1 minute gap. Okay, after 1 minute we'll start again. Just give me 1 minute. Are you getting my sound, students?
Yes, sir.
Okay. Right, so calorimetry. Calorimetry is basically what? Measurement of calorie. Okay, calorie means is energy, metry means measurement. So, measurement of energy, that's the meaning. So, what energy measurement? Whatever energy we are giving to any object, that we can measure, or object is giving to us, that we can measure. Okay, now in this one, what we are going to see? Specific heat we are going to study, latent heat we are going to study. Okay, so that all is under calorimetry. So, okay, fine. So, first thing is thermal heat capacity. Now, what is thermal heat capacity? Thermal heat capacity means is the amount of heat required, to raise the temperature, of an object by unit degree centigrade or unit Kelvin. Okay, unit Kelvin. Okay. So how to write it? We write it as S. I have represented with S. So S basically is equal to Q, the amount of heat required by delta T. Calorie per Kelvin or calorie per degree centigrade or joule per Kelvin. Okay, that is heat capacity. The specific heat we have seen because we already have studied thermodynamics and KTG. The specific heat is what? The amount of heat required, to raise the temperature of unit mass of object by unit degree centigrade or unit Kelvin. Okay, that we are representing with C. So what do you write? C equal to Q per unit mass per unit change in temperature. Oh, delta T, I started writing it smaller. Okay, this is a bigger one, delta T. So here also delta T. C is equal to Q by M delta T. Now this is molar specific heat. That also we know. What will be the difference? In place of this unit mass, we will write unit mole. So C will be equal to here Q by N delta T. Okay, N is number of moles. So these are specific heats, right? Okay, let's see further. So here is a question. But first of all, this specific heat we have written. If suppose we are giving heat to any object, what will happen? Object's temperature increases. So that is written as Q equal to mc delta T. The mass of the object is m, specific heat is C, and if its temperature increases by delta T, then how much heat is given? Q amount is given. So we use this formula. Okay, let's see. Based on this, we will see this question. 300 joule of heat given to object increases its temperature by 10 degrees centigrade. What is thermal heat capacity of the object? He is asking thermal heat capacity from us, but it is also given how much heat is given for how much change in temperature. That's 10 degrees centigrade. Okay, easy question. What we are going to do? See, normally we write Q equal to mc delta T, where C is specific heat. But he is not asking that. What is he asking? He is asking thermal heat capacity. For thermal heat capacity, what is the formula? S equal to Q by delta T. Direct formula is there. So what is the Q given? 300. And what is the change in temperature? 10. Answer is what? 30 joule per Kelvin. That's the answer. Simple. So you can see that in this case we have used Q equal to S delta T. Now this S and this C, what is the relation? This S is actually M into C. Thermal heat capacity is equal to mass of the object into specific heat. Okay. So, if suppose in the same question I would have given mass is half kg, then find out what is the specific heat. That also we could have done. Okay. All right. Next, move ahead. Latent heat. So, specific heat, heat capacity we saw. Now, latent heat. What is latent heat? Latent heat is that amount of heat given to an object so that its phase can change. Okay. Amount of heat required. Amount of heat required to change the phase of the object. To change the phase of the object. That means you want to change the phase, means you want to change solid to liquid, liquid to gas, or gas to liquid, or liquid to solid. So, amount of heat involved, amount of heat transfer. Okay, we call it as latent heat. So, how much is that? Or latent heat, how we represent? We represent this with L. Okay, L is equal to what? L is an amount of heat required per unit mass. Per unit mass, okay, to change the phase. So, L is actually equal to Q by M. Okay, unit joule per kg or calorie per gram or calorie per kg, depends like how it's given, joule per kg. Okay, so if we want heat, so heat is actually M into L. So, is this latent heat constant for an object, or how the transfer is happening? The answer is yes. Latent heat for fusion. Now, two type of latent heat we'll use. Latent heat for fusion and latent heat of vaporization. Latent heat of vaporization. Okay, normally we remember that latent heat of vaporization for water, when water converts into steam or steam converts into water. So, how much is latent heat? 540 calorie per gram. Okay, same way latent heat of fusion for ice, that means when water converts into ice or ice converts into water. What is the latent heat involved? That is 80 calorie per gram. We remember that. And question also will be asked mainly on water and nothing else. Okay, same way if suppose specific heat also we know. Answer is yes, specific heat also we know. Specific heat for water. Okay, 1 calorie per gram per degree centigrade. In ice also we know, but that is not asked in the question. Normally it will be given ice at 0 degree centigrade only. But still, if you want to know, we can. That is 0.5 calorie per gram per degree centigrade. Okay. Right. So these are the values we should know. So okay, let's see how the questions are involved in this specific heat and latent heat and all that. It says heat required to raise the temperature of 10 gram of water by 40 degree centigrade. Okay, heat required to raise the temperature of 40 gram of water by 40 degree centigrade. So are we changing the phase in this one? Answer is no. We are talking about water and you are increasing the temperature of water by 40 degree centigrade. So there is no change in phase. So if there is no change in phase, we will not talk about latent heat. Then what we will talk? Specific heat only, because you are increasing the temperature. So if you are increasing the temperature, specific heat is involved. Okay. So heat required. So okay, fine. How to find? Simple formula. M C delta T. Specific heat is involved. Water specific heat I know. 10 gram of water, so 10 gram. Specific heat of water 1 calorie per gram per degree centigrade. Delta T is 40. Answer is 400 calories. That's all, finished. So if you are increasing the temperature of water by 40 degrees centigrade, then only specific heat is involved. There is no confusion at all. Okay, right. Next you see 60 gram of ice at 0 degree centigrade, heat required to melt it. Now, in this one clearly mentioned that you want to melt ice into water. That means you want to change the phase. When you want to change the phase, latent heat is involved. Okay. Now, ice is at what temperature? 0 degree centigrade. And you want to melt it. Melting happens at what temperature? 0. Change in phase happens, change in phase of ice, that is conversion of ice into water. Conversion of ice into water takes place at 0 degree centigrade. And during this conversion, temperature is not going to increase at all. No increase in temperature. It happens at 0. Once entire ice converts into water, and still if you are giving heat, then temperature of water is going to increase. Temperature of ice will never increase. Okay, first ice will convert into water. Entire water is there. You are still giving it heat, then temperature of water is going to increase. But change in phase, conversion of ice into water only takes place at 0 degree centigrade, constant temperature. Okay, temperature will remain 0. So here, that means you want to convert 60 gram of ice into 60 gram of water. Okay, but temperature remains 0, right? So what is the answer then? So what heat you are going to give? Only latent heat, because temperature of water is not going to increase. So answer is just Q equal to ml, nothing else. Okay, what is M? 60 gram. What is L? 80 calorie per gram. Answer 4800 calories. That's all. 60 gram of ice at 0 degree centigrade converted into 60 gram of water at 0 degree centigrade. Okay, fine. Then, now what? 10 gram of ice at 0 degree centigrade, amount of heat required to increase its temperature to 20 degree centigrade. 20 degree centigrade? How ice can be at 20 degree centigrade? Not possible. Okay, so what is going to happen first? Let's write 10 gram of ice at 0 degree centigrade, then conversion. What conversion? 10 gram of water. 10 gram of water at 0 degree centigrade. Conversion over, then you are increasing its temperature. 10 gram of water of water's temperature increased to 20 degrees centigrade. Okay, so two things are happening. First, you are converting ice into water, okay, at 0 degree centigrade, and then you are increasing its temperature to 20. So, two steps we should write. Okay, so what is the amount of heat given? First, for conversion, that is M into L, latent heat. Then, you are increasing the temperature of water, that is MC delta T. Okay, so 10 gram into 80 calorie per gram, M into L, plus 10 into 1 into 20. What we are getting, this is 800, this is 200, that is 1000 calorie. Okay, first latent heat and then specific heat. Okay, fine. Now what? Amount of heat released by 5 gram of steam at 100 degrees centigrade to convert in water at 40 degrees centigrade and then to ice at 0. Okay, this we will talk later on. Okay, this we are not talking at the moment, we will talk later. But right now what they want? Amount of heat released by 5 gram of steam at 100 degrees centigrade to convert in water at 40. Now, what's happening? Steam is at 100 degrees centigrade. First of all, it converts into water. Again, latent heat is there. So, steam is going to convert into water at 100 degrees centigrade. Okay, conversion always happens at constant temperature. So, steam at 100 degrees centigrade first converts into water at 100. Okay, so steam at 100 degrees centigrade then converts into water at 100 degrees centigrade. Then temperature of water decreases. Temperature of water decreases to 40. Decreases to 40 degrees centigrade. This is happening. Again, two steps are there. Steam converts into water. So, what it does? It releases heat. Steam always has more amount of energy as compared to water. Which is more dangerous? Steam at 100 or water at 100? Steam, because it contains more energy. When it is thrown over any person or anything, first steam gives the heat to that body and converts into water at 100. Okay. Then water at 100 degrees centigrade will give the heat to that body. Understood? So, if you are throwing 100 degrees centigrade water on anybody or 100 degrees centigrade steam on anyone, then 100 gram steam is going to burn him more. Clear? Okay, so steam at 100 degrees centigrade first converts into water. So, Q is ml first. Latent heat of vaporization we will use. Then mc delta T, because now then temperature of water is going to change. So, what is mass? 5 gram. Latent heat 540 calorie per gram. Plus again 5 gram. Now water, then temperature changes by 100 to 40, so 60 degrees. This is heat released. Okay. So, what we are getting? This calculation 0, 1 more 0, 5 4 ja 20, 0. This is 2700 and this is 300. So, this is 3000 calories. This much amount of heat will be released till the temperature of water decreases to 40. Now, what do you want? You want to convert that into ice at 0 degree centigrade now. Already up to 40, this much you have got. Now, further you want to cool the water, okay? Decrease the temperature of water. Okay, so what we will write? Now see, second step. First, Q equal to ml, same thing, okay. Plus mc delta T, but now delta T is different. I am not going to stop at 40 degrees centigrade now. I will go at 0. Okay, so mc delta T dash, let's say. Now what? 0 degree centigrade water you have reached. But now he is saying he want ice. You want to convert water into ice now. Again change in phase is happening. So again ml. Okay. M into L1 we will write. That's all. When water converts into ice, heat is given or heat is taken? If you are giving heat to the water at 0 degree centigrade, what happens? Temperature of water will increase. It will not convert into water, ice. Then what do you have to do? You have to take heat from water. Then only it convert into ice. So take means again heat is released by the system. Here also released when steam converts into water, releases. When temperature of water you are decreasing, then also it is releasing. And when water you are converting into ice, then also system is releasing heat. So that's why the total question is amount of heat released. So what it is here, you already calculated here, this is 2700. So this is 2700 plus mass is 5, this is 1, and this time how much? From 100 degree centigrade to 0 degree centigrade you are bringing. So how much is change in temperature? 100 plus Mass is how much? 5. Now latent heat is 80. This is fusion. Here it was 540, here is it 80. So what is coming finally? 2700 plus 500 plus 400. Answer 3600 calorie. So this much amount of heat is released when 5 gram of steam is converted into 5 gram of ice at 0 degree centigrade. Okay. Alright. Let's see now. Okay, graph we want to know. What graph? That which is showing you latent heat and specific heat and how, if suppose we are going to take ice, okay, ice at 0 degree centigrade and we are going to give it heat, then how it converts, okay, that we are going to see. So here we are going to put temperature, okay, and here Q, the amount of heat that we are giving, okay, and here let's say 0 degree centigrade. So ice is there. Okay, so suppose 0 degree centigrade, certain ice is there and I want to give heat to it. So what will happen? First, when it is ice at 0 degree centigrade, that too, when you are giving heat, first change in phase will happen. So during change in phase, what happens? Is the temperature going to increase? Answer is no. Temperature remains constant during change in phase. Okay. So what he'll do? Make it like this. A straight line. Okay. This is ice. This is showing you ice here first. Okay. So you gave heat. Because of that, its temperature increased. Answer is no. Not increased. Okay. So here change in phase is happening. Then after this, it converts into water. So when you are giving heat further, then temperature increases. It goes like this. This is what? Now here it is water. This is change in phase. Change in phase of ice. So this temperature changes up to 100 degrees centigrade. Maybe this is 100 here. Okay. Right. This is 100. Okay. You further give heat. Now what's going to happen? Is temperature going to increase? No. Because phase change is happening now. So it will be like this. Okay. Again change in phase. Okay. Now what? Steam is there. Now if fully change in phase has happened and steam it is converted, now again if you are giving heat, then again it is going to increase like this. This is how the graph is. Here change in phase means ice converts into water. Ice to water. Here water to steam. So what this is showing you only that during the change in phase temperature remains constant. Here is 100 degrees centigrade, here is 0 degrees centigrade. It remains same till entire is converting into water. Okay. Alright. Mixture problems. Now these kinds of problems are asked more in exam. What is mixture problem? Let's see. And what we have to find? 4 gram of ice at 0 degree centigrade mixed with 20 gram of water at 30 degree centigrade. What the question is asked? Temperature of mixture you say and composition you tell. Okay, two types of questions. One, temperature of mixture. Okay, and composition. Composition means in mixture what is there? Entire is water, ice and water both are there, or steam and water is there, depending on the question. Okay, like here is ice and water. So composition means what it is now. Entire water is there or ice and water both are there. Okay. Alright. So 40 gram of ice at 0 degree centigrade is mixed with 20 gram of water at 30 degree centigrade. Now how to find two things we are mixing? Okay. So first thing is there that if any amount of heat is given, to ice, which is at 0. What is going to happen? It is going to melt to water. It is going to melt to water. Okay. Any amount of heat is given. Now, question is, who is going to give heat? Now, one thing is there. Here its temperature is 0 and here its temperature is 30 and both are mixed. Okay, so we all know that heat moves from higher temperature to lower temperature. Whose temperature is higher? So that means water is going to give heat to ice. And what will happen to ice? It's going to melt. Till what time, till what this water is going to give heat to the ice? Till the temperature of both becomes same. Right? So same means is 0. 0. Then only mixture of the temperature should be 1 only. No, how is that possible that the temperature will be different? Okay. So final temperature should be same only. So that means its temperature is going to become 0. So that means how much heat it can give, that we should see. Okay. Considering temperature of mixture is going to be 0, the amount of heat can be released by water. Okay. So we will say mc delta T. What is mass? 20. Specific heat is specific heat is 1. Okay. And delta T, 30 minus 0, that means 30. 600 calorie it can release if it is fully going to 0 degree centigrade. Okay. How much it can release? 600. Okay. Now the question is, this ice is here. Okay. Now how much heat it requires to fully convert into water first? That also we should see. Maybe this heat is enough to convert it fully. If it is enough to convert it fully, then we have to see that whether the temperature of ice is going to increase. That all we can see depending on the requirement. So let's see first, then we will discuss it. Okay. Right, so amount of heat can be released by water is this much. Now, what is there? Ice. So amount of heat required by ice to fully convert in water. To fully convert to water. How much? ml. Okay. How much heat it requires? ml. Now, how much is mass of ice? Say 40 gram. How much is L? It is 80 calorie per gram. So this requires 3200. Oh. 3200 it requires, but water can give only 600. Water can give only 600 calories. Now the question is, will this ice fully convert into water? Answer is no. Not possible. Not possible. Then what is the answer? What is going to be the answer? Answer will be, this 600 calorie will be used to definitely melt the ice. Okay, but some part of the ice only can be melted. Remaining will remain as ice. Some part only will be converted into water. Okay. One more thing, like 2 questions are asked, temperature of mixture. The temperature of mixture is going to be 0 only. Reason? Because ice is fully not converted into water. Okay. So ice is at 0 degree centigrade only. Correct? And temperature of mixture has to be same. So water will convert into, or water will come to 0 degree centigrade and ice is at 0 degree centigrade. After that, there is no exchange of heat because both are at 0. Correct? So only some amount of ice is melted and converted into water. That is what we are going to find. So here what? We found out how much heat water can give, because water can maximum come to 0 degree centigrade only. Beyond that it can't go. Okay. So maximum amount of heat it can give this much, but ice requires this much. So first answer is Ice fully will not be converted into water. Ice fully will not be converted into water. Then how much it will be converted? That we have to find, because composition we have to write. Okay, so we'll write. Okay, here we'll write amount of ice converted in water. So how much heat we gave? We gave 600 calorie. So with that one, how much amount is converted? See, 600 calories you have given. This is mass converted into latent heat is 80. Okay, so how much mass is converted? We are going to see right now. So 600 by 80. This is cancelled. 60 by 8. This is 2. This is 15. Okay, so that's 7.5 gram. 7.5 gram of ice is converted into water. So how much is water now? Because composition you have to write. So already water was there, how much? 20 gram. Plus, how much ice is converted into water? 7.5. So total water is 27.5 gram. Okay, 27.5 gram water. And how much is ice? It was 40 gram. From 40 gram, 7.5 gram is converted. So how much is remaining? 32.5. So 32.5 gram ice. Okay, temperature of the mixture is 0 degree centigrade. Temperature of mixture 0 degree centigrade, and the amount of ice and amount of water both we have written it. Okay, so like this mixtures questions we solve. I hope it's clear. Okay, let's move ahead then. One more mixture problem. 20 gram of steam at 100, 80 gram of water at 20. Okay, now in this one, who is having more temperature? Steam. So steam is going to heat water. Okay, now how much water you can heat? Up to 100 degrees centigrade. Who is going to give heat? Steam. Now you have to check. If water we have to take to 100 degrees centigrade, we have to take, because mixture has to have the same temperature, right? So if water you are going to take at 100 degrees centigrade, how much heat requires? Whether steam can give it or not. And how steam will give? Because steam is already at 100. So it will convert into water and release heat. Okay, let's see. Okay, right. So let's see that. Right, then solution is here. First is, we are talking about water. Okay, so amount of heat required by water. To reach at 100 degrees centigrade. To reach at 100 degrees centigrade. How much? How to do it? In that one, any change in phase is there? No. No. So MC delta T only. What is mass of water given? Mass of water is 80. Specific heat is 1. And change in temperature? It is 100. You want to take it to 100. So this is 20. And from 100 to 20. So change in temperature is 80. So 80 into 80. How much? 6,400 calories. That much water is requiring. How much steam is having? That we have to see, right? So how steam is going to give this much amount of water, this much amount of heat to water? By converting. Converting means latent heat. Okay. So how much amount this steam possess? How much amount of heat possessed by steam? That we'll see. Okay. So heat released by steam in conversion. How much? M into L. So mass of steam into latent heat. Mass of steam is how much? 20. And what is its latent heat? Is 540. Okay, it is having, I think it's having too much. 20 into 540. So 0, 0, 8, 108. This much calorie it is having, 10,800. And how much water requires to come at 100 degrees centigrade? 6,400. Definitely, water can reach to 100 degrees centigrade. Steam can give it. But will the entire steam convert into water? Because your requirement is just 6,400. And if steam fully converts, it can release this much energy. So we know that now full steam will not be converted because requirement is less. So now the question is what? How much steam will be converted? Correct. Then temperature of mixture is what? 100 degrees centigrade because steam is still left and steam can only be at 100. So temperature of mixture, if suppose only temperature of mixture is asked, then we have already answer. So we will stop solving after this. If we understood that yes, still steam is there, that means 100 degrees centigrade is temperature. Leave it. But now here we want composition also. So for composition we are solving. So what we learned here, we learned it that steam is not fully converted. So our question is how much steam is converted. Okay. So here is steam is not fully converted into water. Not fully converted into water. As heat required by water is less than heat content of steam. Less than heat content of steam. Okay. Now, how much amount of steam converted into water then? Fine. Amount of steam converted into water. Steam converted into water. How to find? Again same, because latent heat only for conversion. So Q required, how much Q required? This. M converted into L. Q required 6,400. Mass we are finding. L is 540. 0 and 0 gets cancelled. So M converted is equal to 640 by 54. Okay. So 320 by 27 is coming. 320 by 27. How much is going to be here? 1, 27, 1 ja and 5. 5 will come. Again 1. Point. I will be 23. Okay. 230. Okay, some 11 point something. So 11 point something gram of steam needs to be converted into water. Then entire water can come to 100 degrees centigrade. So what is the composition then? Composition is 80 gram of water already there and around 11 point some gram of steam is converted into water. So 80 gram plus 11 point something gram water. Okay, and 20 minus 11 point something gram steam. This is composition. Okay, so water has increased and steam has decreased. Right, so this way we can find composition. Let's see one more question. Okay, let's see what this is. X gram of ice at 0 degrees centigrade plus Y gram of water at 40 degrees centigrade. what should be x by y? So that entire mixture is water at 0 degree centigrade. So entire mixture becomes water. That means this ice need to convert fully into water and 0 degree centigrade. That means this water also should come at 0 degree centigrade, and whatever amount of heat it is releasing, that entirely used by ice and converts into water. That is only, no? Simple question, you have to understand that, that's all. So, how water will release the heat? It will release when it will come to 0 degree centigrade. Okay, because it says that composition, rather temperature of mixture is 0. So, this water has to come to 0 degree centigrade and this ice has to convert fully. So, it just equate it. Okay. Latent heat of ice. Latent heat of ice equal to heat released by water. Heat released by water. Okay. So, here what? ml, m ice into L, because full ice has to convert, so directly I am writing m ice into L, and here mass of water into specific heat into delta T. So, what is mass? Y. Specific heat is 1, delta T is 40, because 40 to 0 it has to come, and here X into its specific heat is 80. Oh, sorry, latent heat is 80. Okay, so he is asking what? X by Y. So, X by Y appears to be 1 by 2. Okay, so that's 1 by 2. Simple. Then next question is, steam at 100 degree centigrade is passed through 20 gram of water. 20 gram of water at 10 degree centigrade. The mass of water present will be if water acquires temperature of 80 degree centigrade. Okay, so you can see that the question says that when steam of at 100 degree centigrade is passed through 20 gram of water, temperature of water is going to increase to 80. Then how much will be the mass of water? One thing is clear, this steam is heating the water, but this steam cannot take the temperature of water from 10 to 100, only it could raise it up to 80. So definitely it means entire steam has converted into water, point number 1. Then when it converts into water, then it converts into water at 100 degree centigrade, right? The other water is definitely at less temperature. So what happens then? From this converted water at 100, again heat is going to the remaining water. And finally, the mixture's temperature is coming 80 degrees centigrade. Okay, so we have to find how much is the mass of water present. So mass of water actually is 20 gram of water plus mass of steam, because temperature of the mixture is 80. That means full steam is converted into water. Understood? If it would have been 100 degree centigrade, then there was a chance that maybe some amount of steam is not converted into water. But here temperature is 80. So that means entire steam is converted into water. Okay, how to do? See. Okay, so now what to do? First thing is, steam at 100 degree centigrade is there, and there is 20 gram of water. Okay. How much is mass of steam? Let's assume mass of steam is m. Right? Now what we know about this one, this steam is going to convert into water. That means latent heat is involved. Okay. So amount of heat released by steam. First is what? Latent heat, m into L. Correct? So now m into L, when it happened, 100 degree centigrade steam converted into 100 degree centigrade water. Now what's going to happen? Further, the steam's temperature is going to decrease because it has to go to what temperature? 80. Okay, so what has happened? You converted into water at 100. Now water at 100 is going to go to water at 80. So that means specific heat, mc delta T. So this much amount of heat is released by this steam to go to 80 degrees centigrade. Now who's taking that heat? This water. Okay, amount of heat accepted. Who is accepting this? So this amount released should be equal to the amount of heat accepted by this water. Okay, so what you will write? Heat accepted by water. Now directly I am writing its mass, okay, 20 into specific heat 1 into change in temperature. How much? 10 to 80, that's 70. Now both I am going to equate. Okay, so let's see. M we have to find here, so M is here. Okay, latent heat is 540 calorie per gram, we all know, plus M. Now it's converted into water, so specific heat is 1 and change in temperature here is 20, 100 to 80. Okay, that's equal to what? This is 1400. Okay, so what this is? 540 plus 20, 560. 560 M equal to 1400. This cancelled. So M equal to 140 by 56. So 14, with 14 I am cancelling this 10 and this is 4. So 2.5 gram is steam, that's all. The steam mass is 2.5 gram, but is he asking steam's mass from us? No, he is asking mass of water. So mass of water, earlier mass of water was 20 and now this is steam also converted into water. So how much steam was there? 2.5. So total mass of water at 80 degrees centigrade is 22.5. Okay, mass of water at 80 degrees centigrade is how much? 22.5 gram. Okay, this is how mixture questions are done. Okay, one more question we will do. Okay, directly steam and ice will mix. So let's see. Question is 1 gram of ice mixed with 1 gram of steam. And what do you have to do? Find temperature of mixture and composition. What else? Okay, what's going to happen in this case? Now, steam's latent heat used to be very high, 540. Its latent heat is very less. So once steam you are mixing with ice, the first thing that will happen is ice will convert into water at 0 degrees centigrade. Then steam's temperature is 100 because we are saying its latent heat is very high. So now what? Ice converts into water and water at 0 degrees centigrade, but steam is at 100 only, no? So then water starts going towards 100. So first thing we will find is how much amount of heat required by ice in conversion to water plus water in moving from 0 to 100 degrees centigrade. That is requirement because mixture is there. Ice is steam is already at 100, water at 0. How much temperature you can raise for water? To 100. So we will raise it and we see that how much requirement of heat is there. Then we will ask steam whether you have that much amount of heat or not. If it has, then we will take water till 100 degrees centigrade. If it doesn't, then mixture's temperature will be less than 100, as in the previous question we did. In the previous question what we did? We first saw that how much is amount of heat required. And then we said that amount possessed by steam is less, so it entirely converts into water at 100 and then further temperature of steam is going to become less, it comes to 80. So like this you have to see that how much is heat requirement and how much is heat available. Accordingly we have to solve. Then only mixtures question you can do. Okay. So see now, here what I am saying, ice latent heat is less. So first we will see that how much heat is required for conversion of ice. Okay. So solution says amount of heat required by ice. Amount of heat required by ice. Required by ice is ml. Okay. So 1 gram into 80 calorie per gram, that is 80 calories. That is having 540. So a lot more, right? Only 80 it is asking. Definitely it can give. Now it will take this temperature of this water, which is converted already, to 100 degrees centigrade. Okay. So amount of heat required by water to reach 100 degrees centigrade. Okay, how much water is there? 1 gram. So 1 gram into a specific heat 1, change in temperature 100 minus 0, that means only 100 calorie it requires. So 100 calorie, 80 calorie, definitely 180 calorie only. This can release 540 calorie if it converts into water. And you require how much? 180 calorie only. What is the meaning of that? Entire steam will not convert into water because your requirement is only 180. Steam will be there. So temperature of mixture is 100. Very simple. If ice is there in the mixture, temperature of mixture is 0. If steam is there in the mixture, temperature of mixture is 100. Okay, so we saw that requirement is only 180, it can release 540 calories. So temperature of mixture is 100. Now question is what is the composition? So for composition, you see that heat required is how much? 180. Now this who will give us? Steam. So for this how much steam need to be converted? Mass of steam converted into its latent heat. So 180 equal to mass converted into 540. So M is saying 1 by 3 gram. 1/3 of a gram is converted. So how much is remaining? 2/3 is remaining, 1/3 is converted. So what is composition? Composition is how much water? 1 plus 1 by 3 gram water and 2 by 3 gram steam. Understood that? 1 by 3 gram of steam converted into water. So what is water now? 1 plus 1 by 3. And how much is steam? 2 by 3. Okay, so 1.33 gram of water and 0.66 gram of steam is there in the mixture, the composition. Okay, this is how we should be solving these mixture questions. Okay, one more question we will solve and then today's class will finish. So calorimetry is also over and tomorrow's class we will see heat transfer then. Okay, conduction, convection, radiation, and we will move ahead after that. Okay, so what is the question then? The question is the quantities of heat required to raise the temperature of two solid spheres, of radius r and 1.5 r and 1.5 r by same temperature. Okay, or 1 Kelvin you say, two solid spheres of radius r and 1.5 r by 1 Kelvin. What we have to do? Ratio shall we find? The quantities of heat required to raise the temperature of two solid spheres of radius r and 1.5 r. Okay, The ratio will do. The ratio. Okay. The ratio of quantities of heat required to raise the temperature of two solid spheres of radius r and 1.5 r by 1 Kelvin. That's question mark. Okay. See what we have to do. These two solid spheres are there and their temperature we have to raise. So, quantity of heat required. So, you say Q1 by Q2 you have to find. Okay. Now, Q1 by Q2 is what? Say M1 C delta T, and this is M2 C delta T. Okay. The ratio of Q1 and Q2, M1 C delta T and M1 2 C delta T. So, delta T is given 1 Kelvin only, so forget about this. If they are from the same material, then C is also same. So, then it is M1 by M2 only. Now, M1 and M2 is what? What is M1? Say density into volume. If they are same material, then density also same. So, that is now V1 by V2. So, V1 is what? 4 by 3 pi r cube, and this is 4 by 3 pi 1.5 r cube. So, 4 by 3 pi cancelled, r cube and r cube cancelled. So, this is 1 by this 1.5 I am writing 3 by 2, 3 by 2 cube. So, it becomes what? 3 cube is 27, 2 cube is 8. So, it will become 8 by 27. So, Q1 by Q2 ratio will become 8 by 27. Okay. So, like this also question can be asked from you. Alright, this has nothing to do with excelling mixture and all that. This is a simple question depending on specific heat. Okay students, so today's class we are finishing here. Calorimetry we finished and expansion we finished. Tomorrow's class will be based on heat transfer. Okay, so take your notes here. I am giving you the QR code, just take that. Okay, here it is. Take the scan it and you will have the notes. Okay students, see you then tomorrow morning. Bye bye.
Thank you, sir. Thank you.